In this video, we're going to look at completing the square. Completing the square is a method to change quadratic expressions in a form, or quadratic equations in a form, so that then they can be used to find either maximum and minimum values, or else they can be used to solve the quadratic equation. So it's an alternative to either solving by factorizing or solving by using the quadratic formula. So we're going to look at how we go about doing this. Okay, the first thing to notice is if you expand x plus a squared, it gives you x squared plus 2ax plus a squared. So this coefficient, this a, is double it, and that's where you get the coefficient of the x, and then the last term is just this thing squared. So for example, if I was to do x plus 4 all squared, it would give me x squared plus 8x plus 16. So notice this 8 is twice of this thing, and this 16 is this 4 squared. Okay, so if we have a look at this and how we can use this. So first thing we're going to do is complete the square for these expressions. So here in this first one, we're just going to go equals, and all we're going to do is we're going to rewrite this as being x plus, and we're going to half the coefficient of that thing. So that's 10, so it gets half to give you the 5, and that gets squared. We've still got our plus 8, but you must remember then to take away the 5 squared. So if you were to do this out the long way, I'll get rid of this line in a wee minute, but if you were to do this out long, just to prove it would be the same. X plus 5 upon x plus 5 would be x squared plus 10x plus 25 plus your 8, then minus the 5 squared, which is minus the 25. So it does give you the same thing, x squared plus 10x plus 8. So to do this, basically, all we want to do is just, we'll get rid of all of that, we don't need it. To do this, all you want to do here is add in half of your coefficient of your x. So it's x plus the 5 squared, and then you must remember to take away this bit squared. So we have to sort this out and see what this gives you. We want to leave the square bit, so x plus 5 squared, it stays as it is, and that's plus 8, and then that's minus 25. So that's just going to be x plus 5 all squared, and 8 minus 25 would be minus 17. Okay, let's look at the next one, and we'll be referring back to the first one to see what we're doing. So here, first thing we want to do is to sort out what's in the squared bit, and what's in the squared bit is half the coefficient of minus 7. Half the coefficient of minus 7 is minus 3.5. So minus 3.5 is what goes in this bracket. So what we need to do, so notice what we did in the first one, you did your 10, and you took away, you divide it by 2 to give you the 5, so that goes inside the bracket. And then you also need to remember to take away the 5. So over here, we need to remember that we're taking away the minus 3.5 squared. Now, write it that way, please. That is correct. That's the correct way to do it. And then we'll go to the next line. That's now x minus 3.5 still. Nothing has changed there. And then plus, and then just do that in your calculator. 100 minus the 3.5, 10 minus the 3.5 squared. So that's just going to be 10 minus 3.5 squared will be 12.25. And if you do that, you're just going to get x minus 3.5, that's squared, and then minus 2.25. Okay, this last one looks a little bit weird. Here, my a value, remember what we have, we have x squared plus 2ax plus a squared is equal to x plus a all squared. So our 2a is equivalent to here, 2a equals minus 1, so a is equal to minus a half. So for this one, it's going to be x minus a half squared, and then you've got plus 0 really. So then you're just taking away minus a half all squared, which is going to be x minus a half all squared minus, and minus a half is going to be 1/4, and that's what we have. We'll just leave that one as fractions. Absolutely nothing wrong with that at all. Okay, next we're going to actually use this method to solve equations. So we'll just go through this again. So we're working down, and the next line here is going to be, we're going to rewrite the x plus 4x as x plus 2 all squared. Remember, we half the coefficient of this thing to give you your 2, and then we have a minus 8, and then we have to remember as well then to take away that 2 squared. That's equal to 0. And then from here on in, it's just a wee bit of tidying up. So that's just going to be x plus 2 all squared minus 8 minus 2 squared, which is minus 4, is equal to 0. So that's x plus 2 all squared equals, and the minus 8 and the minus 4 go across the other side, and they will become 12. So then x plus 2 all squared is equal to 12. That means x plus 2 is equal to plus or minus the square root of the 12. A lot of people forget about that one. And then x is equal to minus 2 plus or minus the square root of 12. So what I've done here, I brought that minus 2 across, and it becomes minus 2. Okay, hit that into your if you hit minus 2 and then put root 12 into your calculator, it'll come out as plus or minus 2 root 3. Okay, same exact idea in the next example. Left hand side, it's half of the coefficient of this thing would be minus 3.5, so minus 3.5 goes into that bracket, and then you need to remember to take away minus 3.5 squared on the left hand side, and that's equal to 14. So we just do a wee bit of rearranging. X minus 3.5 squared still inside the bracket. This minus 3.5 squared has to go across the other side, so we have 14 plus minus 3.5 squared. Fire that into your calculator and see what you get. So when I did that, I got 26.25. So that was x minus 3.5 squared was equal to 26.25. So x minus 3.5 itself will be equal to plus or minus the square root of 26.25. And I've just put these things as fractions, just makes it a wee bit nicer. So instead of minus 3.5, I've written that as minus 7 over 2. And if you do that on your calculator, here you'll get plus or minus the square root of 105 all over 2. So that just as 105 is being square rooted, the 2 is not being square rooted. That means if you bring this minus 7 over 2 across, you'll have 7 over 2 plus or minus the square root of 105 all over 2. And you can write that a nice way as 7 plus or minus the square root of 105. Just by taking common denominator, then it's all over 2. Okay, one more of these. We'll just do the same thing again. The coefficient of the x is just going to be 5. So half of that you're going to get 2.5. So I'm just going to say that becomes x plus 2.5 squared, and then I've got my plus the 10, and then I'm going to take away the 2.5 squared again. That's equal to 0. And then if we sort all of that out, that will just become x plus 2.5 squared plus 10. 2.5 squared is 6.25. So 10 minus 6.25. So if we bring that across, we'll tidy it up first in this one. This is a bit of a weird one. We have this, and then that's going to be minus 3, it's not, it's going to be plus 3.75 is equal to 0. And then if you have x plus 2.5 squared equals minus 3.75. Okay, right. Now here, if you did bring the square across, it becomes square root, and you cannot have the square root of a negative number. So in this one, we'll just say there is no solution. No solution can be found, as you cannot find the square root of a negative. And that's it. Okay, you're now ready to do your algebra and equations exercise 2F. We're going to see now how completing the square method can be used to find the minimum values in quadratic expressions. So we're going to jump straight to the answers here and get started. So it says here, using completing a square, find the minimum value and when it occurs. So the first thing we want to do is we want to rewrite this using completing the square. So the coefficient of x is 12, so we're going to write this as x plus 6 squared plus 10 minus and the 6 squared. Okay, which just tallies up to be x plus 6 all squared plus 10 minus the 6 squared, which is 36, so that's just x plus 6 all squared minus 26. Okay, if we have a look at this thing at the minute, what we have now changed our expression to be x plus 6 all squared minus 26. Now let's focus on the x plus 6. X plus 6, the smallest this thing, x plus 6 squared, sorry, the smallest thing this could be is 0, because anything squared gives you a positive number. So the smallest thing this could possibly be would be 0, and that will happen whenever x is equal to minus 6, because minus 6 plus 6 gives you 0, 0 squared gives you 0. So the overall smallest thing that this could be would be minus 26. So here we just say the minimum value is equal to minus 26, and that happens when x plus 6 equals 0, i.e. x is equal to minus 6, and that's it. So to find it, once you get it in this form, just say the minimum value is whatever you've got outside the bracket, and then it happens when the bracket is equal to 0, and then however that works out. So in this case it was x plus 6 equals 0, so x is equal to minus 6. Same idea in this one. Our coefficient is minus 3, so x squared and half the coefficient is going to be minus 1.5. Sorry, that shouldn't be an x squared, that should just be an x. That's x minus 1.5, and that's going to be squared. Then plus your 5 minus 1.5 squared. So if you go on from that, that's going to be x minus 1.5 squared. And then if you do 1.5 squared or minus 1.5 squared, you got 2.25, so that's going to be minus 2.25. So that's going to be x minus 1.5 squared, and then that's going to be plus 2.75. So again, the minimum value is going to be equal to this thing, and it happens when this thing is equal to 0. So just say minimum value is equal to 2.75, and that happens when x minus 1.5 is equal to 0, i.e. x is equal to 1.5. Okay, you are now ready to do your algebra and equations worksheet exercise 2G.